Okay, dear student, in previous class we discussed about buoyancy, Archimedes law and buoyancy. Today we will discuss about the law of floating, law of flotation, law of flotation, flotation. Law of flotation means equilibrium. Flotation means means equilibrium. Equilibrium. Equilibrium means the net force is zero. Net force is zero. Net force zero means if suppose this is an object, if force is applied in this direction, or in this direction, but there is no change of the position of the object, then we can say the net force is zero. The net force is zero. So, law of flotation means equilibrium. Equilibrium means the net force is zero. Suppose, and the body is in equilibrium, so we can say if the body is in equilibrium, the net force will be zero. Suppose this is a container. This is a container or vessel anyway, and this is the liquid. And this is the liquid, and there is a cylinder, and the cylinder is here. This is the cylinder. This is the cylindrical object. Cylindrical object. So this portion is inner side to the into the water, and this portion is upper side or outside of the water. The weight of the object is acts along this direction, weight, and we know upper thrust, that means buoyancy, acts along the upper direction, or so this is the buoyancy. We denote it U. So for equilibrium, U equals to W. That means there is the object is in equilibrium in this position. So weight and upper thrust buoyancy will be equal. So we can say when a body is in equilibrium, then we can write weight of the body equals to up thrust. Okay, up thrust, and or we can write weight of the body equals to weight of the fluid displaced by weight of the displaced water by object. Weight of the body equals to weight of the displaced water by object. So this is the law of flow. So when the body is floated and when the body is immersed. Okay, come on. You have to remember this: weight of the body equals to up thrust, and weight of the body equals to weight of the displaced water by object. Okay, come on. Now we know up thrust equals to rho F BF into G. Rho F was the density of the fluid, BF was the volume of the fluid. Volume of the fluid means the immersed part of the object into the liquid. Suppose this is the liquid and this is the cylindrical object. So BF will be, this portion will be BF. This portion is immersed into the liquid, so it will be the BF. So displaced volume of the displaced water equals to the volume of the submerged part of the object into the liquid, and G is the acceleration due to gravity. Okay, come on. Now, suppose there are three positions of the object in the liquid, into the liquid. Suppose this is the vessel. Here, this is the liquid, and this is the position of a cylinder. Okay. Three conditions. There is another condition, another. Here is the position. The second figure is this is the position. Third figure is liquid, and this is the cylindrical object. Okay, three position of the object into the liquid. So here from here, in this case, suppose the density of the object is rho s and density of the liquid is rho f. If rho s is smaller than rho f, density of the solid or object is smaller than density of the liquid, then object is float. Object is floated. This is the condition. And here the rho s is greater than rho f. The density of the solid is greater than the density of the fluid. In this case, the object is submerged into the liquid. Okay. So that case will be rho s equals to rho f. So density of the solid equals to the density of the fluid. And this is the position of the object just touches the upper surface of the liquid and submerged. So this is the, we can say this is the limiting flotation. Limiting flotation. Okay. Limiting flotation. So rho s is smaller than rho f. It's also the condition of flotation. Rho s equals to rho f. It's also the condition condition of flotation. When we solve any mathematical problem according to the condition of flotation, then we use this condition, rho s equals to rho f. Rho s equals to rho f means that Ws equals to buoyancy. Ws equals to buoyancy. Okay. Come on. Okay. Suppose there is this is the liquid, and
sir, can you explain the limiting?
Yes.
Sir, can you explain the third part again?
Yes. This is the object, and this is the cylindrical object. The area of the cylindrical object is A, and the height of the cylinder is H. Come on. So, according to the condition, we know F net will be 0. F net equals to 0. F net 0 means weight of the object equals to the buoyancy. Okay. Here weight of the object acts in this direction. Weight of the object, this is the MSG, and buoyancy will be rho f BF into G. Okay. Come on. MS equals to koto? MS equals to rho s BS into G equals to rho f BF into G. GG. So rho s VS equals to rho f VF. Okay. Now you can say the body is fully submerged into the liquid. The body is submerged fully into the liquid. So the volume of the object and the displaced liquid will be same. The volume of the object and displaced liquid will be same. So BS equals to BF. Understand it?
স্যার
Yes?
স্যার এখানে কি এফ নেট বলতে নেট ফোর্স বোঝানো হয়েছে?
Yes, net force.
থ্যাংক ইউ স্যার।
So I can say here the volume of the solid equals to the volume of the displaced liquid, because the body is fully submerged into the liquid. So the volume of the solid and volume of the liquid will be same. So BS equals to BF. So we can write rho S equals to rho F. This is the condition for limiting flotation. Understand?
Yes, sir.
Okay. So it is a one condition, rho S BS equals to rho F BF. Okay, come on. Suppose if the position of the object in this, suppose this is the position of the object into the liquid, and height is h, and submerged part into the liquid is x. X or HF, and this is HS, suppose. Okay. Now we know rho S VS equals to rho F BF. Okay, come on. Volume, we know V equals to A into H. Volume, cross-sectional area into height. Okay, come on. Now, volume of the solid, the rho S A HS. The cross-sectional area of the cylinder is A. So we can write rho F, and volume of the displaced liquid. The volume of the cross-sectional area of the, in this portion also A. So cross-sectional area, the submerged part of the object into the liquid, it is HF. So rho F AHF. So we can write A rho S HS equals to rho F HF. This is the another condition for the flotation. Rho S HS equals to rho F HF. Okay, come on. Now we can solve a numerical problem. Come on. This is a vessel, and this is the position of the liquid, and here is a cylinder. This is the cylinder. The submerged parts of the cylinder into the liquid, it will be L by 4, and it is 3L by 4. 3L by 4. And density of the water, rho W equals to 10 to the power 3 kilogram per meter cube. What is the density of the solid? What is the density of the solid equals to what? Okay, come on. Here the cylinder is in equilibrium. We can consider it. Here the volume cylinder is in equilibrium, so we can say net force equals to 0. And on the other hand, we can say the weight of the cylinder equals to the upthrust. Weight of the cylinder, weight acts in this direction, and upthrust acts in this direction. Okay. W equals to U. Solid. So MSG equals to rho F BF into G. So we can write rho S VS G equals to rho F VF G. So we can write rho S VS equals to rho F VF. Rho S, we do not know the value of rho S. and BS. Suppose the cross-sectional area of the cylinder is A, and the height of the cylinder is at the plus at. So 3L plus 4 plus L by 4 equals to rho F of the cylinder is rho W, liquid is rho W, and volume of the submerged immersed part of the cylinder is A, and suppose this is the L by 4 into L by 4. Okay, so we can write AA submerged, so it will be L into rho W L by 4. Okay, come on. Now we can write rho S equals to rho W by 4. Rho W means 10 to the power 3 by 4. That means 250. So rho S equals to 250 kilogram per meter cube. This is the density of the solid.
স্যার আপনি উপরের পার্টটা আবার লিখে দিতে পারবেন যেটা মুছে ফেলছেন?
ওটা ফর্মুলা বসাই করে ফেল আগের মতো।
U equals to W.
এটা তুলতে পারি না।
WS equals to U. WS equals to NS G. Rho F VF G. Rho S VS G equals to rho F VF G. After that, this is the line. Okay. Please first. Okay, come on. There's another numerical problem. Okay. How many penguins the mass of the each penguin is 30 kilogram. How many penguins can a disc-shaped ice float? The diameter of the disc is 15 meter and height or thickness is 1 meter. Support before fully submerged underwater. Fully submerged underwater.
Penguins এর পরে কি লিখছেন?
The mass of the each penguin is 30 kilogram. MP, mass of the penguin, submerged underwater. Okay. How many penguins can a disc-shaped ice float support before fully submerged underwater? Okay, come on. I cannot draw a penguin. Suppose. Okay, come on. Penguin. Suppose this is a penguin. And this is the disc plate. This is a disc plate. The diameter of the disc plate is D. D equals to 15 meter. And height of the disc is H equals to 1 meter. Okay. And this is the penguin. Okay, come on. Now, we had MP equals to 30 kilogram, D equals to 15 meter, and H equals to 1 meter. And how many penguins discs stepped and different submerged to suppose? These penguins are seen in seawater. We know the density of seawater equals to, what is the density of seawater? 1025. Oh, come on. Suppose 1030 kilogram per meter cube. And density of the ice equals to approximately 917 kilogram per meter. Understood? So, this is the picture. Now, we can consider what is the number of force acts in this case. There is a weight of a penguin, it acts in this direction, WP. Okay. And there is a weight of the ice, it acts also in this direction, WI. And upper thrust of the liquid on the ice sheet, that is the U. Okay. So we can write here for equilibrium position, WP plus WI equals to U. Weight of the penguin, weight of the ice equals to buoyancy. Okay, come on. Weight of the penguin, it means mass of the penguin into G, weight of the mass of the ice into G, and it will be the buoyancy will be rho F BF into G. Suppose the number of penguins, how many penguins? Suppose the number of penguins is n, small n. Suppose the number of penguins is small n. So mass of the penguin will be NMP. Suppose this is the capital MP. So NMP into G plus MIG equals to rho F BF into G. Okay, G. We don't know. We know MP, so it's MP plus MI. We do not know the value of MI. Okay, MI. So we can write rho I VI equals to rho F VF. Density of the ice into volume of the ice equals to density of the fluid into volume of the fluid. Okay, come. So NMP equals to rho F BF minus rho I VI. Rho F BF minus rho I VI. Okay, but we do not know the value of volume. What will be the volume? Volume of the ice sheet. Because the volume of the ice sheet and the volume of the displaced water will be equal. Because the ice sheet is fully submerged underwater. So we can write NMP equals to, it will be rho F B minus rho I V. And we can write NMP equals to B rho F minus rho I. Rho F minus.
Sir, N ta ki?
Yes, N number
N.
of the penguins. Okay, come on.
Sir, number of the penguins এখানে কিসের বদলে সে অ্যাড করা হলো?
Total mass of the penguin is empty. If the number mass of one penguin is empty, the number of n will be an empty.
Oh, okay, sir. Thank you.
MP was the total mass of the penguins.
স্যার
Okay.
ভিআই থেকে স্যার ভি কেমনে হলো শুধু তবে এটা বলবেন?
The ice is fully submerged into the liquid. Ice fully submerged underwater. So the volume of the ice and the liquid will be same. Water will be same. So BF equals to B and BI equals to B. Understand? If
Yes,
a
sir.
body is fully submerged into the liquid, the volume of the object and volume of the displaced water will be equal for this reason. So n equals to V rho F minus rho I by MP. We do not know the value of D. So V equals to pi R square 1 by 4 pi D square H into rho F minus rho I by MP. Okay. So we can write pi D square H into rho F minus rho I by 4 MP. Now we can put the value. Pi means 3.1416. D means 15 square. H means 1. Rho F means density of the seawater. It will be 1030. Density of the ice, it is 1917. 4 into penguin's mass is 30. So the result will be 3.1416 into 225 into first bracket 1030 minus 917 and divided by 120, and it will be the 665.6. 665.6. The fraction number is not applicable, so number of penguins nears about to 665. This is the number of penguins. Understand? Yes or no?
এটা 30 আছে কাঁদছিস কেন? এখন তো 11টা বাজে নাই।
Please
Hey, mic
mute the
off.
mic. Okay.
স্যার আমরা স্যার 666 কেন নিলাম না, কারণ ফুললি সাবমার্জড ওয়াটার যদি 665 যদি পেঙ্গুইন যদি না হয় তাহলে?
This is the fraction number. Fraction is defined.
ইয়েস স্যার।
For
স্যার
this
তাহলে
reason.
তো আমরা 666 ও নিতে পারতাম।
No. You have to consider in this from this 665 before the point, before the decimal. Decimal পূর্বে যেটা সেটা নিবা. Okay. There is another math we can here. Okay. This is the water. The density of the water is 0.1 gram per cc. 1 gram per cc. And there is a ice. The density of the ice is 0.9 gram per cc. And here is the suppose kerosene. Kerosene. The density of the kerosene rho K equals to 0.8 gram per cc. What is the ratio of length of ice? What is the ratio? What is the ratio of length of ice
স্যার ডান পাশে গুলো কত ভ্যালু দিচ্ছেন একটাও দেখতে পারতেছি না
1 gram per cc, 0.9 gram per cc, 0.8 gram per cc. What is the ratio of length of ice which is present in water, which is present in water, which is present in water to kerosene oil, to kerosene oil, which is present, please mute the mic, present in water to kerosene oil. Consider the system is in equilibrium. The system is in equilibrium. Okay, come on. According to the condition, we know weight of the ice equals to, here you can see there are two liquids. One is the kerosene, another is the water. So, okay. So the weight of the ice in this direction, buoyancy of the water in this direction, UW, and buoyancy of the kerosene in this direction, UK. Okay. For equilibrium, we can write the weight of the ice equals to buoyancy of water plus buoyancy of kerosene, UW plus UK. So we can write MIG equals to rho W BW G plus rho K BK into G. MI means rho I VI G, rho W BW into G plus rho K VK into G. Understand? So we can write rho I VI equals to rho W VW plus rho K VK. Okay, density of the ice is 0.9, volume of the ice. Okay.
G deducted from the both sides.
Yes, yes. Suppose the submerged part into the water is X and submerged part into the kerosene is Y. Okay. So the total is X plus Y. Suppose the cross-sectional area of ice is A and height is X plus Y. And rho W it is 1 and submerged part into the water is X. So A into X plus density of the kerosene is 0.8 and the volume is A into Y. Okay. So we can write A. So 0.9 X plus Y, X plus 0.8 Y. Now we can multiply in both sides by 10. So 9X plus Y equals to 10X plus 8Y. 9X plus 9Y equals to 10X plus 8Y. 9Y minus 8Y equals to 10X minus 9X. So we can write Y equals to X. So the ratio of water to kerosene. So water X by Y equals to 1:1. So the ratio of water and kerosene are equal. Understand? Okay.
Yes, sir.
Now discuss about another law that is called the Pascal law. Pascal law. Pascal law is applicable only for fluid. Pascal law is applicable for closed container. Closed container. Suppose there is the container or vessel and this is the liquid. A movable piston is here. This is the movable piston. It can move down or forward. If you apply force in this direction or pressure in this direction, the liquid of this vessel comes out by this way. By this way. On the other hand, you can say, suppose there is a bottle, water bottle, and if it is fully into liquid, if you pressure in this portion, the liquid go upward direction. So pressure is exerted in this object, the pressure is distributed and water is or emerged from the vessel. If the container is closed, if the container is closed, the pressure cannot be emerged from the container and the pressure is acts in this direction, in this direction, in this direction, in this direction. So the pressure is acts in all directions. Suppose when you pump a football by a pumper, you can see the football, the shape of the football is expanded in all directions. And so we can say the pressure, if pressure is applied in an enclosed container, it is exerted in all directions. It is acts in all directions. And equally, there is no diminished of the pressure. The pressure are acts equally distributed or transmitted in all directions. And the pressure acts perpendicularly to the surface of the container. And so in a word, we can say in an enclosed fluid, if pressure is changed in any part of the liquid or fluid, then the change of pressure is transmitted and diminished in all the other part of the fluid. We can discuss about this in our next class. I hope you are safe at home and you will be prepared for your examination. Okay, thank you.
Assalamualaikum, sir.